Right, so in this video clip we're going to look at everything you need to know about working with pie charts, and predominantly there are three different skills that you need to be able to demonstrate with pie charts. First of all, you need to be able to draw them, you need to be able to read information from them, and you need to be able to make comparisons between information shown on pie charts. So this first sheet here is just basically taking you through the stages that you need to learn and practice. So when you're drawing them, you need to know from the context of the question how many data items, and it's more often than not people, but not always, that the pie chart has to represent. So how many people the whole have to fit into the whole pie chart. You should know from your properties of circles that a whole pie chart is 360 degrees. So you can work out how many degrees each person that the pie chart needs to represent will get. And you do that by doing 360 divided by the population of the data. Then you work out each slice by multiplying that single number of degrees by how many are in each category. And then we go ahead and draw it, and we'll be practicing that shortly. When you're reading from them, sometimes you can just spot a common fraction. So you can often spot if there's a slice that's 90 degrees, which is a quarter of the pie, or thirds and 2/3 are another common angle size, slice size that you will spot. But if it's not thirds or quarters or halves, then what you would do is measure the size of the angle of the slice and write it as a fraction out of 360, and we'll see some practice of that. And then perhaps the most important part of all is that when you're asked to compare pie charts, you need to be aware that you can't say one slice on one pie chart has more people or whatever than a slice on the other pie chart, unless you know that each pie is representing the same population size, the same number of people or whatever. Otherwise you can't compare them. So with those bullet points in mind, let's take a look at some questions. So one sunny Sunday morning, the owner of Lizzie's Ices ice cream van recorded the number of ice cream sales. So you can see here 22 vanilla ice creams were sold, 12 chocolate, and so on. Draw a pie chart to represent the number of ice cream sales made by Lizzie's Ices. You should show how you calculate the angles for your pie chart. So the first thing we need to do is work out how many ice creams there are. Now I'm not sure whether this was on a paper 1 or a paper 2, so just for the speed of it we'll go for a calculator. So first of all I need to work out what the total ice cream sales were. So the total ice cream sold, 22 plus 17 plus 12 plus 15 plus 6 is 72. So I have to divide 360 degrees by 72. So degrees per ice cream will be 360 divided by 72, 5 degrees. So each ice cream gets 5 degrees of that pie, but we don't want to turn it into 72 slices because 22 of those ice creams were vanilla. So all I have to do now is each of those 22 get 5 degrees, so 22 lots of 5 tells me that the vanilla gets a 110 degree slice. This one, 17 times 5 is an 85 degree slice, 60 degree, 75 degree, and 30 degrees. And they should add up to 360. If they don't, you've gone wrong. So now we draw it. Generally easier if you have a 360 degree measurer. Now then, how am I going to get the light away from that? There you go. Right, so it's given us a starting line. So there's my first point to begin. So the 0 needs to line up along the line, and the centre cross of the measurer needs to be on the centre of the circle. And then you need to decide whether you're going to build your slices going up the page or down the page, because that will depend on where your scale is. So if I'm going to go up the page, then my scale starts 0, 10, 20, so it's the inner scale. If I'm measuring down the page, then it's the outer scale, 10, 20, 30. I'll go down, so the first one is 110 degrees. So 0, outside scale, 110. Draw a little mark, get a ruler. So that's vanilla. Now, the next bit is really important and where lots of students go wrong. To start drawing the strawberry slice, I now need to move my 0 to line up at the start of the next slice. So I've turned it so the 0 now lines up down there, and I've got to draw an 85 degree angle, which is there. So that's strawberry. And chocolate is 60. Turn. Line the 0 up with the start of the next slice. Cross in the center. 60 degrees to there. And that is chocolate. Banana is 75 degrees. Line the 0 up with the start of the next slice. 75 degrees. So that's banana. And then the last one is toffee, which I shouldn't have to measure because it's the remaining one. So just to see how accurate we are, you can see there. That lines up with 30 degrees, 10, 20, 30. So I'm happy that I've got that right. Okay, so that's drawing it. On the same Sunday morning, another ice cream van, Cameron's Cones, sold 90 ice creams. Of these 90 ice creams, 18 were chocolate flavour. Who sold a higher proportion of chocolate flavour ice creams? So the higher proportion means that we want to turn it into a fraction initially, but then probably a percentage in order to make it easier to compare. So for Cameron's, he sold 18 out of 90 that were chocolate. Now, if I was writing in a maths test and you scored 18 out of 90, I would write that on top of your page like that, 18 out of 90. So that's how you'd write it as a fraction. And then to compare that with Lizzie's, there were 12 chocolate out of 72. So both of those have now been written as proportions, but because the denominator, the bottom of the fractions, they're out of a different number of sales, it's not easy to say which one has got the greatest proportion. So in order to make it easier, what we would tend to do is to turn each of these into percentages so that they're out of 100, and then you can compare them directly. So on your calculator you can type these in pretty much as they're written. So fraction button, 18 out of 90 times 100 So 20% of Cameron's were chocolate, and for Lizzie, 12 out of 72 times 100 is 16.6%. So now it's a direct comparison. You can see straight away that Cameron's sold a greater proportion. So Cameron sold a greater proportion of chocolate. Right, so that was drawing and turning into proportion. Question 2. The pie charts below represent the number of boys and the number of girls in 2 year groups. There are 150 pupils in year 7, so that whole pie represents 150 pupils. There are 40 more boys in year 8 than there are boys in year 7. How many girls in total are there in year 7 and year 8? So when I was talking about reading from pie charts, I was saying there are common fractions to spot. Quarters and halves are the obvious ones, but thirds and 2/3 are the next, and that's what these have been split into. That's a third of the pie, and that's 2/3. If you're not sure, you can always measure them. So if we wanted to measure the boys, what you'd have to do is extend the line so that I can see where it cuts my angle measurer. Center, I've lined the 0 up with the top, and you can see there that I'm going down the blue scale, 0, 10, 20, and that comes to 120 degrees. So that's 120 out of 360. Well, if you multiply 120 by 3, you get 360, so that's the same as a third. So if you're in doubt, you can always measure it, but you should be able to see that as a fairly standard representation of a fraction. So I know there are 150 children in year 7, and a third of them are boys. So in Y7, boys equals 1/3 of 150. To find a third, you're going to divide by 3. 150 divided by 3 is 50 boys. There are 150 children in total, so if 50 are boys, so Y7 girls will be 150. No, they won't. Sorry, it'll be 100. 150 in total, so you take the 50 off, 100. Now there are 40 more boys in year 8, so in Y8 boys will be 50 and another 40, so that'll be 90 boys. And if you look at the fraction of year 8, 2/3 of them are boys, 1/3 of them is girls. So there are twice as many boys as girls. So Y8 girls, that's 2/3, that's 1/3. So we divide that by 2, 45, and then the question is saying how many girls are there in total. So total girls will be 100 in year 7 and 45 in year 8, which is 145 girls. So that's a pie chart question where you don't actually have to calculate anything with the pie chart. It's all to do with thirds and 2/3 fractions. Okay, another drawing one. The winning team of the Six Nations Rugby Tournament from 2000 to 2014 is recorded in the table below. Use this data to draw a pie chart to illustrate the number of times that each team won the Six Nations Tournament from 2000 to 2014. You must show how you calculate the angles of your pie chart. Okay, so the first thing we need to do is work out how many times each team won. So we've got Ireland, 1, 2, twice. Wales, 1, 2, 3, 4. England, 1, 2, 3, 4. France, 1, 2, 3, 4, 5. And Scotland didn't win it at all, and Italy didn't win it at all. So although there are 6 nations, we're actually only going to be having 4 slices on our pie chart. So total will be 15. So each win will be 360 divided by 15. .24 So Ireland get 2 lots of 24 degrees. .48. Wales 4. Which would be 96. England 4. And France 5 lots of 24. Excuse me, 120 degrees. So those are the angles we're going to draw. Now this time they haven't given us a starting point, so I'll just draw a line to kick us off. And the first angle I'm going to draw is Ireland, 48 degrees. 0 up the page. Outer scale, 40, 48 degrees. Be as accurate as you can with your mark. Ireland. Wales, 96 degrees. Remember, you have to turn your angle measurer to the start of the next slice. 90 degrees, 95, 96. Wales, England was also 96. France will be the remaining one, so if I measure that, it should be 120 degrees. Yeah, it is. So that's France. Okay, so let's draw another one. Here we have another fraction comparison. So the pie chart shows the proportion of boys to girls in Class A and Class B. Recognizing those, I'm hoping you can see straight away that I've got 1/4 and 3/4 in that one, and 1/3 and 2/3 in that one. There are more pupils in Class B than Class A. There are 4 boys in Class A. So if that's 4, then the girls will be 3 times as much, because they've got 1 4 there, 1 4 there, and 1 4 there. There are 1.5 times as many girls in Class B than in Class A. How many boys are there in Class B? So in Class A, girls in Class A, would be 3 lots of 4, 12. So the number of girls in Class B will be 1.5 times as many, so that would be 12 plus a half as many again, which will be 6, will be 18. So I know that there are 18 girls, and that's 2/3. So 1/3 would be half as many, so there'll be 9 boys. Uh, 18 divided by 2, 9 boys. So that's that. Again, working with fractions rather than having to measure anything. Question 5. A sports magazine used the following pie chart to illustrate the countries from which the first 18 European Championship League winners came. How many times did a team from Spain win the championship? Now this time it's not obvious what each angle is as a fraction, so this time we do actually have to calculate it. So we need to work out how big the angle of Spain is to find out what fraction of the whole circle it represents by Spain. So centre across the centre of the circle, the 0 lined up at the start of Spain, and I'm working in this direction, so I'm going on the inside scale, 100 degrees. So Spain have 100 out of the 360 degrees of that pie, and that pie represents 18 wins. So 100 out of 360 of the 18 wins gives us Spain's victories. So on a calculator, that would be 100 out of 360 times 18, 5 wins. You need to be able to deal, and just for the speed that I'm working through these, I'm using a calculator, but it's possible these would come up on paper 1, so you have to make sure you are well practiced at finding fractions of quantities. Question 6, similar to the previous one. Sarah plays a game 72 times. In each game results in Sarah gaining 0 points, 1 point, 2 or 3. The pie chart below summarizes the results of the 72 games played. Use the information from the pie chart to complete the frequency table below, and then calculate the mean number of points Sarah scored per game. So, no points, you don't have to measure them, they've given us the angle. 60 out of 360 times the whole pie represents 72. So 60 out of 360 times 72, 12 games. 1 point, 30 out of 360 times 72, 6 times. 2 points, 150. 30. For 3 points, 120. 24. So that's worked out the frequencies, how many times each number of points were won. And then to turn that into a mean, we've now turned this into a question which is a mean of group data. So for the mean, we need to know the total number of points. Well, there are 12 games where no points were scored, so that's no points. There were 6 games when 1 point was scored. 1 times 6 is 6. 30 games when 2 points were scored, so in total that would be 60 points. And 3 games when 24 games when 3 points were scored, which is 72. So the total number of points is 6 plus 60 plus 72, which is 138, divided by how many games were played? 72. So we do 138 divided by 72, and we get 1.9 points per game is the mean. So that's a nice question because that's combining 2 skills, reading information off a pie chart and then turning it into a mean of group data question. Question 7. 36,000 people took part in a survey to find out their favourite type of TV programme. Pie chart shows the results. So we're working with 36,000. How many people chose drama as their favourite type of TV programme? So I need to measure that angle there because it's not obvious. So centre, on the centre, the 0 I've lined up along the bottom of the slice, so I'm going along the blue scale to read off 100 out of 360, and then to find out how many it is I've got to multiply that by 36,000. Fraction button, 100, 360 times 36,000, so 10,000 people chose drama. How many more people chose sport rather than news as their favourite type of TV programme? So if we measure these 2 angles now, sport, I'm measuring the outside scale is 115. And news is 55. So there's different ways you can go about answering this question. You could work out what the difference in the angles are and find out that fraction of 360 of 36,000. Chances are you'd be more likely to now work out what each of these are. So that's the way that I'll do it. First of all, what that fraction of 36,000 is. So 11,500. But for this one, it's 55 out of 360 times 36,000, which is 5,500. So the difference between the 2 is 6,000. So 6,000 more. And then the last part, twice as many women as men chose talent shows as their favourite type of TV programme. Calculate how many women chose talent shows. So twice as many women as men chose talent shows. So we can see there a quarter, 90 degrees, a quarter of the 36,000 chose talent shows. So we can work out the number of people who chose talent shows is a quarter of 36,000, which is 36,000 divided by 4, 9,000. Twice as many women as men. So if we were to write that as a ratio, it would be a ratio of 2 to 1. For every male, there were 2 females. So in turning it into a ratio question, you can see that in total there were 3 parts. So 9,000 divided by 3 is 3,000. So 1 part will be 3,000 to 2 parts, which will be 6,000. So calculate how many women chose talent shows. 6,000 women. And then the final part of the question, 1,000 people were asked, should news programs include details of the weather, yes or no? 70% of the people answered yes. A pie chart is to be drawn to represent the answers to this question. What size would the angle be to represent the answer yes? So if the whole pie chart is 360, 70% of 360 will be the size of the angle. So different ways of doing this. You could write 70% as 70 out of 100 times 360, or you could write as 70% as a decimal straight away, 0.7 times 360, or you could use the percentage button on your calculator and then you would write it as 360 times 70%. Whichever way you choose to do it, that's the percent way, you'll end up with the same value, which is 252 degrees. So there you go, that's a session on dealing with pie charts.